Alright guys, so as you know, Vishal is not going to be here today. I'm Srinjoy, I'm a technician in the Ting and Haber labs. I do sequencing, mostly RNA sequencing, the wet lab work, but over the last year I've been working a lot with Vishal doing computational analysis, and I took his very first alpha version of this course. But today, I understand that you guys learned the nuts and bolts of R last Monday. And so today we're going to go over control loops and functions in R. We'll see how far we get, but I think we should be able to cover most of this PowerPoint today. So what are control structures? And also, sorry, feel free to interrupt me with questions. As usual, I don't really know how Vishal runs his class, but I assume that he's open to questions whenever, so certainly just interrupt me as we go. So control structures are found in pretty much every object-oriented programming language, and specifically control structures in R. They basically allow you to control the flow of your code, so to speak, meaning that you don't want to just run line by line and have to repeat things, or in order to repeat commands, you don't have to write the same line over and over again. Rather, you can use loops and other such kind of structures. So in R, we're going to go over if, else, for, while, repeat, which is not that useful, break, next, and return. So yeah, some of them are more useful than others, but we'll be learning about all of them. Alright, so if, this is probably the most intuitive of them all. So the general structure of an if control structure is you have if, and then in parentheses you follow it up with some sort of condition. This has to evaluate to a Boolean, either true or false. And then in the in the brackets following it, you have some sort of commands. You can choose to follow this if statement up with an else statement, which will execute if the condition in the parentheses following the if is false. The bottom part of the slide kind of illustrates that you can use this if-else kind of structure multiple times in a row. So you have this if followed by else if. That way you can evaluate two different conditions and basically create kind of like a tree of kind of decisions, so to speak, based on trues and falses of your various conditions. All right.
In the conditions, can you evaluate a function or something?
Sorry, what was that?
Do you have to just feed it a value, or can it evaluate stuff?
No, it can evaluate any sort of statement, yeah, as long as that final statement evaluates true or false.
Okay.
Alright, so let's look at some real examples. These are pretty straightforward. If x is greater than 3, set y to 10. Otherwise, set y to 0. Right. So you can either, or both of these are essentially the same, they evaluate the same way, but you can either set the conditions and assign the kind of value to a variable within your if-else, or you can do the if-else, find the output, and then assign that output to your variable. These are two different ways of doing the exact same thing. And I don't think either is necessarily better or worse in terms of readability or efficiency or any of that. Make sense? Alright. Right, and as I was saying before, the else clause is not necessary. You don't need to have an else following an if. You can just, basically the else is else do nothing. So you just do if something, do something. Alright, so for loops. These are basically loops over which you iterate some sort of variable, and you have to basically assign it successive values from a sequence or a vector. So yeah, these are pretty useful because as you learned in terms of the atomic structures of R, you have vectors, you have lists, and you have matrices. Most of those, it helps to have some sort of function that can iterate over all of the values of a vector or all of the rows or columns of a matrix. So for loops can be pretty useful. We'll learn later that R has built-in kind of functions that kind of do a for loop, but in a slightly different way. These are called apply functions. And those are generally more accepted as better for ways of coding in R. But for loops are still useful, and they're very kind of intuitive, especially if people learn Java or other sorts of object-oriented programming languages. I'm sure you're pretty familiar with for loops. So here, for example, for I in 1 to 10, this is actual code, this is not like pseudocode. You can write I space in 1 to 10 and it'll basically successfully assign 1 through 10 to I and iterate over that. And it'll just print the values of I. Alright, so let's look at some examples. So, I guess a surprise at the top, the 3 loops have the same behavior, but let's go through them really quickly. So we set x to a, b, c, and d. So the first one is kind of like the loop we just saw on the last slide. For I in 1 through 4, print x of I. So it's going to print x of 1, x of 2, x of 3, and x of 4 successively, and therefore print a, b, c, and d. Alright, for I in seek along x. Alright, so seek along is just a function that essentially returns exactly what you see in the first loop. It returns 1 to 4, but if x was a vector of length 5, it would return a sequence of 1 to 5. So seek along is kind of just a fancy way of returning a sequence from 1 to the length of your vector. So that obviously does the same thing as the first loop. The third loop I think is the most interesting of them. For letter in x, print letter. So this is showing that you can basically just return the values of x using this other kind of temporary variable called letter. And letter will iteratively be assigned each of the values in the vector x and be looped through them. So that is perhaps more readable version of this loop rather than doing like I in 1 through 4. And finally, this last one is just an example showing that if your loop is only one line, you don't have to put curly brackets around it. Does that make sense?
Can you seek along these? Like what
Yes. So seek along, essentially what it does is it'll take your, actually, no, I can't over here. This is no board. if you take your, so if x is any vector, it basically just takes the length of that vector and returns a sequence from 1 to that number in integers. So if x were of length 10, it would return a sequence of 1 to 10. So essentially this seek along evaluates to 1 through 4. So it's kind of just like a fancy way of doing that.
So how would the code be written? So would it be the first 2 lines and for the seek along?
Yeah.
So it would have for I 1 to 4. You need that before you go to the seek along, right?
No. You
No?
just need to assign your
Define
vector.
x?
Yeah, you should define x, and then you can seek along x, and that will return your.
So in the previous statement would be x is equal to 4, for example, right? Would that be sufficient?
Yeah. If x was equal to 4, though, your vector would only be of length 1. You see what I'm saying? So seek along takes the length of x.
Oh, the length of it.
Yeah. So it's
It's not
basically
the value of it.
not the value of x, exactly. So it'll basically take the length of x and return a sequence of integers that show that evaluate to the numbers from 1 to the length of x. So it's basically something that you use to iterate along something. So if you want to generalize some version of code, you don't know if vector x is going to be a length 4 or length 10. Instead of using the first loop, which will always only take a value of 1 to 4, you can do seek along x, and that way your code is robust for a vector of length 4 or a vector of length 10, because it will always take the length of x and create a sequence of that length. Alright. Right, so nested for loops, so just as you can kind of iteratively use if and else ifs, you can also nest for loops. You can basically have a for loop within a for loop. One of the more practical examples, which is the example given here, is that you can basically iterate over both the rows and columns of a matrix by using 2 for loops within one another. As I kind of mentioned before, there are more kind of concise ways of doing this that we'll learn later, but if you're having only for loops at your disposal, this would be one of the more practical ways of nesting for loops. So this is saying for I in seek length of number of rows of x, which is a matrix, and then within that, for j in the seek length of number of columns of x, print x of ij, which is basically, it's going to print basically all of the values in your matrix in order. So seek length, I don't know why this is always complicated, see, because it's that. So seek length is kind of like seek along, but seek length, this is what you're saying actually. Seek length takes a number as its input and creates a sequence of that length. So this one, if x was 4, you did seek length of 4, it'll return a vector of 1 to 4. Or seek along, you have to give it a vector of x length, and it'll create a vector of 1 to x. Regardless, you don't have to really use these seek things.
There's n row and n column.
Right, so n row takes a matrix and tells you the number of rows in that matrix, and n col takes a matrix and tells you the number of columns in that matrix. So this is basically just printing out each of the values of your matrix by iterating along each row and then each column. Right, be careful with nesting. Beyond like kind of 2 nested for loops, it gets kind of confusing as to what the behavior of your loops are supposed to be, and it gets more or less difficult to read, even if you get the performance to be correct. All right, while. While loops are kind of like the other major version of loops. They're kind of like a combination almost of like if and for to some extent. While loops test a condition, kind of like an if, so it has to be a Boolean. If it's true, you execute whatever commands are inside the loop, and then once it's done iterating those commands, it'll check the condition again. And if the condition is still true, it'll run through the loop again. It'll keep on going through the loop until the condition that you first evaluate is false. As many of you can already see, and this is important, while loops can potentially result in infinite loops if you don't write them properly, because if your loop doesn't do anything, has no bearing on the Boolean that you originally give it, if that Boolean will never turn from true to false, it'll just keep on going over and over again and it'll never stop.
Can you force R out of a loop when you've accidentally done this?
Yeah.
How-
You can just tell it to stop. There's like a little stop button, especially in our studio, there's like a stop button. You can just tell it to stop.
Okay, cool.
Yeah. The way to, if you want to be more cautious, you can we'll learn soon that there's a break command. And so if say you wanted this to only run, if it ran more than 100 times just to stop it, you could write like another line, like use some other counting thing and count the number of times it's gone through the loop, and say like if count is greater than 100, break. And that way you'll break out of your loop once this is iterated 100 times, since you probably, if you don't expect the behavior to iterate through this loop 100 times, then you should probably stop it. But yes, there is, if you do accidentally create an infinite loop, there is a relatively GUI interface to just kind of break it so it stops doing stuff. So in this loop, count is 0, and so while count less than 10, print count, and then count equals count plus 1, so it's just adding up from 0 to 10. But again, that's kind of like the major check that you want to check to ensure that your while loop is not going to go on infinitely, is to make sure that every time you go through your loop, you're getting closer and closer to breaking your loop, essentially. Getting closer and closer to turning your Boolean true to a Boolean false. Because if that's not happening, you're never going to get there. But yeah, I believe you can write any while loop as a for loop, so there's not really a benefit to writing each either way. It's really just how readable your code is. Right, and sometimes, so this is true, I don't know why this introduces all the way here, this can be true for any of these, right? If, for, or while, you can evaluate multiple conditions in a test. So as you guys, I hope, learned with Boolean operators, you can use this and. So if you look in the while line, so while z is greater than or equal to 3, and z is less than or equal to 10. So this is basically that and is a Boolean operator that is the and operator. You can also do or, which is not on here, it's that like solid bar. It's two of those bar, that's or. So you can basically and or your Booleans together to create like a more complex kind of true or false metric, so to speak. So let's go through this code really quick. Oh, so yeah, conditions are always evaluated from left to right. So it's kind of like order of operations. This is important because you have to like kind of use parentheses and whatnot to make sure your Boolean evaluates the way that you want it to every time. So anyway, so while z is greater than or equal to 3, less than or equal to 10, you're going to print z, right? And then so your coin, so R binom. So R binom is a random binomial number. This is actually a pretty useful function for simulating data. We can kind of go through the details at some other point, but basically it's saying we're going to do one observation, we're going to do one trial, and we want a probability of true or false being 0.5. The probability of true being 0.5. So it's basically a coin flip. Simulating a coin flip, right? It's binomial tests, and then one observation, so it's simulating one flip. So basically, if coin is 1, you're going to add 1 to z, and otherwise you're going to subtract 1 from z. So this is simulating, as it says there, a random walk. So you have basically 50% chance of going forward, 50% chance of going back, and you're going to see it's either going to end up going below 3, or you're either going to end up being 3 or greater than 10. And that's when the loop will break. You can figure out what z was. So it's kind of like a cool little fun little thing. You can see how many times you have to flip the coin to get z either above 10 or 3 or below. Or sorry, less than 3. Yes.
So what are the 3 parameters being in R binomial?
Right. So the first parameter is number of observations of a given trial, and the second parameter is the number of trials you're running, and the third one is the probability of true.
What were the 3 things? Sorry,
Sorry.
So the first one is,
So the first one is number of observations per trial.
so if it was 2, that would be 2, like it would do it.
It would do it twice.
Twice, okay.
Yeah.
Alright.
And the second one is number of trials. So you could basically, if you did 2-2, it would do 2 coin flips. It would do 2 coin flips and 2 observations of each coin flip.
So you get 4 results.
Right, you get 4 results.
So if it turned head once and tails once, you get head, tail, tail.
Right. Yeah. Alright. So repeat, like I said, is not super useful. Right. So basically, repeat is something that you can set. It's not exactly a loop. Well, it is. It's an iterative structure. Basically, whatever is in the brackets after repeat will continuously be run through until you tell it to break. This is obviously pretty dangerous because if you forget to put in your break, it will definitely run infinitely because it doesn't run on any sort of condition. But we'll see an example. Essentially, you have to. Maybe we won't see an example. That's interesting. Let's see this one.
I think
There we
that's
go.
before it.
Right. So repeat initiates an infinite loop. Right. They're not really all that commonly used, but they have the uses. Again, the only way to break it is the only way to stop it from iterating infinitely is to call a break. So basically, it's similar to a while loop, honestly, because you're basically going to keep on repeating something until a Boolean turns false, and once that Boolean turns false, you can break it. But you have a little more control over what the conditions are that cause it to break. So here's an example. They really like using extremely complex examples of very simple things, but here we have compute estimate. I actually tried Googling this. That's not like in R, so I don't know exactly. That must be someone's own function. It's some function that does something apparently. So you're gonna say, right, if x of 1, x1 minus x0 is less than this random value, we're going to end the loop, otherwise you're going to set x0 to x1 and then do it again. So again, you can easily see how this can be rewritten as a while loop. You can just take that if statement and make that a while boolean, and then put the else within the while loop. So again, in terms of practical use of this, I'm not sure how useful it is, but it's good to know that. More importantly, it's good to know that you can break any loop. You can put breaks either for loops or while loops if you have some sort of condition that you absolutely don't want it to run the rest of the loop, to continue running the loops. If a certain condition is true, you can just break it. Makes sense? Right. So it's dangerous because no guarantee it will stop. Right. It's good to set a hard limit on the number of iterations. I was saying the same thing for while or for do the same thing, and then report whether it finished naturally or it finished because it was broken. All right. More importantly, functions. Actually, not more important. Sorry. So that's like the end of control structures. I don't know if you guys have any further questions. So again, to recap, it's if else, for, while, repeat, repeated break, kind of go together. The most important ones probably are if else and for/while, whichever one you choose to use. And they're all reasonably straightforward, I think. Alright, so functions. The functions are kind of going to be your bread and butter since, you know, I mean, there are a lot of predefined functions in R and in packages that you can download, but a lot of the times you're going to want to run something specific, whether it's something from manipulating a certain matrix to a certain way, or just like running a combination of like, you know, like some combination of like operations, or, you know, combining multiple commands into a single line. You can basically define your own function. So functions are created using the function directive. So function is a reserved word in R, because it's basically telling R that the following is going to be stored as a function. But what's interesting in R is that functions are essentially objects, so they're similar to variables. So if you see in the code here, you define your function, but you assign it to what seems to be a normal variable, f. So that says there, functions are first class objects in R. They can be treated pretty much like any other R object. Right. Functions can be passed as arguments to other functions. This is just like you can write a function that uses like the mean function or like the R binomial function or something. You can take those functions and use them in your own function. You can also, you know, we'll see this when I don't think we're going to do apply today, but in apply is a function, but you apply functions. You apply is a function that applies functions to other things, so that's a great example of functions being passed as arguments to other functions. And functions can be nested, so you can define another function inside a function, which is, I don't think, super useful, but worth knowing that you can actually do that. Okay. The most important thing, for some reason, is relegated to like the second sentence of this. So the return value of a function is the last expression in the function body to be evaluated. So if any of you know Java you have to specifically say return this, and return is kind of this reserved word that you must use to have your function return anything. Here you don't have to say return anything, just the last value that is evaluated in your function will be what the function returns.
So let's say if you wanted to return another value, let's say halfway down your function, could you do that too?
No, because they can only have one kind of output. So you basically have to define a second function and basically separate them into two different things.
So the return is not used at all?
Return is not used at all. Exactly. I mean, the other way of getting around that is somehow defining it so that the multiple values that you want to return are put into one object, like put into a vector, or put into a list, or put into a matrix, or a data frame, or something like that. Alright, so let's hopefully go to some examples.
Can you put a if-else function in?
Yep.
You can put if-else in a function, right?
Yeah, within the function body, it pretty much operates just like another block of
But that still doesn't help you to return another.
Yeah, no, exactly. You can return one or the other, but not necessarily both of them.
Yeah.
Exactly. Alright, so this is, right, so functions have arguments, so essentially when you call a function, you need to call it on something. That's kind of the one difference between function and like normal like objects, like other like data frames, matrices, vectors. The function needs to be run on something. And so these arguments are included in the function definition. This is going to be slightly confusing until we see an example, but I'm going to go through this and then maybe we can come back to this. So the formal arguments are arguments that are included in the function definition. The formal's function returns a list of all the formal arguments of a function. More important than that, I think, and probably more practically, if you have a function and you see a function and you don't know what it does, the fastest way of doing it, especially in RStudio, is, I don't know, if a shell like this, you can just do a question mark and then write, and then immediately following it, write the name of the function, and that will bring up kind of like the help the like kind of FAQ on that function. We'll bring up like examples of how to use it, what are all the arguments that it can take, what are the names of all its arguments, and so on and so forth. But if you wanted to literally just see the formal arguments of a function, you can use this formals function instead of this question mark. I don't think it's that useful, but also can be done. Right. Importantly, not every function call in R makes use of all the formal arguments. So if you like look at something like the linear regression function, the LM function, it has like a ton, like probably like 20 or 30 arguments. You don't have to assign values to every single one of them because a lot of them come with defaults, kind of default values. So right, function arguments can be missing, or it might have default values. So right, some function arguments don't really need to be defined; they're kind of like optional arguments, and others just have default values. So we don't have to specify a value when you write a function. So anyway, let's get to hopefully an example, and this will hopefully make some more sense. Okay, this is kind of like an example. Argument matching. So all this we were talking about, right? The formal arguments of a function. So here we're going to look at the SD, the standard deviation function. So I'm going to go over there. So essentially, this function, standard deviation, takes, here it's only taking 2 arguments. You have x, which is essentially the data that you want to take standard deviation of, and you have this na.rm argument that is basically true or false, and it's basically saying, do you want to remove NA arguments in your data before taking standard deviation? Basically, if your NA remove is false, that means you can't take standard deviation of NA, which means it will return NA if you have a single NA in your data when you try to take a standard deviation. But if NA remove is true, then you will remove any NAs and take the standard deviation of whatever data is left. So here, what this is trying to show, so argument matching is essentially when a function is defined, was what the last slide was trying to explain to you, you have to define it with a number of arguments. So if I were to define a new standard deviation function, and I wanted it just to take a list of values and basically remove NAs if I wanted it to, those would be, I would say, function of x, comma, na.rm. And then in my when I define that function, I will use x and na.rm to kind of evaluate and basically do the math behind taking a standard deviation. But what this is saying is when you call a function, it's good to specify that my data is being assigned to x and that false is being assigned to na.rm, but that you don't have to do that. So all of these evaluate to this same thing to some extent. So if I just do standard deviation of my data, in the back end, R is saying that my data corresponds to x. This is getting a little confusing. So what do we do here?
So R norm 100 would give you what? Would give you like that one number between 0 to 100? Is that?
No, so it's going to give you
R norm?
100 random numbers from a normal distribution.
Oh, 100 random numbers.
Yes. So there are actually, you can feed it more parameters, but this is actually another great example of argument matching. So you can feed it other parameters, but this first one is just the number of values that you want. And then you can say in other arguments to this function, you can say, I want like the mean to be this and the standard deviation to be this.
Yeah, so but for that, so it gives you 100 random numbers between, like, does it?
Yeah, so it defaults to 1 and -1, I believe. Like, between 1 and -1.
Oh, okay. So R random gives you, okay, so that's the default setting.
That's
the
the default
100, the 100 random numbers between -1 and 1. Okay.
I think so, yeah. So let's look at the standard deviation. So basically, when someone defined, someone somewhere defined standard deviation function. And so they did. But basically, I'm not going to write out what they actually define the function as, but this is kind of like So this is the call of how do you define a function. Okay, so you're defining SD. This is your reserved.
Now, okay, there we go.
You got it?
Yeah.
Cool. Great. So essentially when you're calling, so let's take this first example. Standard deviation of my data. So it's going to look at your argument. So you only gave it one argument, and this function takes 2 arguments. But it knows it's going to try to match. Right. So this is what I'm saying. So our function arguments can be matched positionally or by name. So SD of my data, it's going to try to match that positionally. So it's going to say, you only gave it one argument, so I'm going to try to match that to the first argument in the definition, which is this x. So that it will do correctly. So because you want my data to be x, because that's what you're taking the standard deviation of. Alternatively, you can specify exactly that x equals my data. So you more explicitly say that I want my data to be assigned to x and not to NA remove. Not that assigning it to NA remove would work, because that would throw an error. Just looking for a Boolean, not a list of values. So similarly, well, I guess the default is to false. So similarly, you can explicitly say both that you're assigning my data to x and you're assigning false to NA remove. So the important ones are kind of down here. So this one, you've reversed the order of the NA remove and the my data kind of inputs, but by specifically referring to them by their argument names, it doesn't matter what order you put them in. That's because you've used these names. If I were to just put in SD of false comma my data, that would throw an error, because it's going to try to assign false to x and my data to NA remove. So if you didn't put these x equals and NA remove equals, it would throw an error. But finally, if I specifically say NA remove is false, and then just put my data, it will revert to trying to positionally match my data, and it'll go back and try to fit it to the first argument that was not assigned a value. So essentially what it's doing is, okay, so you're saying NA remove is false, so it knows like that's taken care of. So now when it sees my data, it goes back and says, from the start, what arguments have not been defined? It's like, oh, okay, x hasn't been defined, so I'm going to assign my data to x. And this would work even if, and maybe it does, maybe SD does have more arguments. It would still positionally match it to the first argument. Right, even though you can do this, it doesn't really make a whole lot of sense to go and like mess around with the order of all of these arguments, since especially if other people are reading your code and they're used to seeing the arguments in the original order, it gets kind of confusing. But that's also a good reason to actually put these names in, because even if you may know, you may be very familiar with a certain function, even if, especially if you're the one who wrote the function, it's good to explicitly write what is my data being assigned to, what is false being assigned to, because if someone is unfamiliar with your function, it makes it more readable for them to understand what's being assigned to what.
So SD function always comes with x and na.rm, right?
Yes.
That's something that's already built into the program.
Right, so this has already been defined, like this is a predefined function in R.
And what is na.rm, by the way?
Right, so na.rm is basically a Boolean that, if it's false, what it's saying is that if your data that's being assigned to x has an NA in it, it's not going to remove it. And so it's going to try to take the standard deviation of all of your numbers, and that will return an NA, because you can't take a standard deviation of an NA. Whereas if na.rm is true, it will remove all the NAs and take the standard deviation of whatever's left. So I think it defaults to false because basically R wants to let you know. I think a lot of functions do this. R wants to let you know when you have an NA because it assumes that you did not intentionally have an NA there. So therefore, all the downstream kind of functions that act on something, a data set that have an NA in it, will continue to return NAs. So basically, nothing doesn't give you any like false data without you realizing that you had an NA that was introduced into your data.
So the default setting for that is false, then, right?
It's false, right?
But you can assign it to be true. And
Exactly.
If it's true, then it will remove all the NAs and it will give you the standard deviation
Yeah.
without the NAs.
Exactly. So
Right.
if you don't care that you have NAs and you know that you will have NAs in your code, then you can tell it to be true, and it will just take away.
And the way, like, let's say if I didn't know SD had these two functions attributed to x and na.rm, I can just put question mark SD and it would give me that, right?
Exactly. And it'll show you all of the arguments and the parameters that you can take.
Okay.
Alright. Let's move that. Okay, so I think these slides potentially should have been been in a better order. But this is basically what I was trying to get at. So this is argument matching. So, right, so you can either positionally match your arguments, or you can match it by name. Right, and when you match an argument by name, it's taken out of the list of unassigned arguments, and the rest of your arguments that are assigned without a name are then positionally matched. So here, this is what I was talking about, the linear regression function. This is the LM function. It comes with all of these different arguments that can be assigned values. So formula data, subset weights, any action. The rest of these you'll notice have default values. So QR, true, false, false. These are all, but these you can also change. But if you look at these two different function calls, here you have data equals my data, y proportional to x, model equals false, 1 to 100. So let's go through and see how this is matching it. So data equals my data. So it's going to go, it sees data, it's going to match it to data. Alright, so data is now assigned, y proportional to x. This doesn't have anything equals this, so it's going to try to match it by position. Goes through, it sees, okay, formula is the first unassigned argument, so therefore y proportional to x must be the formula. It's going to assign formula equals y proportional to x. Model equals false, it's going to match this by name again. Okay, it's going to switch this to false. Then 1 to 100, again, it's going to go through formula has been assigned, data has been assigned, subset. So it's going to assign subset to 1 to 100. So you can do it like that, or you can do it like this, where these first three arguments are all positionally matched. So y proportional x is going to match it to formula, my data is going to match it to data by position, 1 to 100 is going to match it to subset by position, finally model equals false, we'll match it to model based on the name. You can actually also do model by position. You basically have to do like comma, 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 comma. You don't have to put anything there, but you just have to keep on putting commas until you get to the right position. But that is obviously very unreadable, so I wouldn't tell you to do that. But you could also do that. That makes some sense. I think this is a better practical example of what argument matching is. It's not all that critical, but obviously because in most functions, if you assign the wrong argument to the wrong argument, it'll probably throw an error. The chances of you getting the right type of value for a given argument is probably pretty low. But it's good to understand how is it matching it. And again, a lot of the times it is better to explicitly state what the name of the argument that you're trying to assign a value to is, so that when someone reads your code, it's a little easier for them to understand what's going on. Right, so this is basically what I just said. Most of the time, named arguments are useful, especially when you have a long argument list, and you want to use the defaults for everything except for an argument near the end of the list. That's kind of what it was doing with model. So if the only arguments you want to change are towards the end of the list, it's better to just specify them instead of putting a bunch of commas as placeholders and then getting to the right position. Right, named arguments also help if you can remember the name of the argument and not its position on the argument list. Right. That's basically the same, like, if you don't want to memorize, like, when you plot something that it goes x, y, and then, like, x min, x max, like, y min, y max, you could just, and you know the names of the arguments, you can just use those instead of trying to figure out which position does x go in, which position does y max go in. But again, generally, I think it makes sense to use argument names when calling a function. A lot of slides on this. All right. So function arguments can also be partially matched, right? Which is useful sometimes. So basically, this is kind of like the 3 steps that R takes to try to match your arguments to the ones that are defined in a function. First, it'll check for an exact match of your argument to any of the arguments that are in the definition. Then it'll check for a partial match. Notably, this has to be like a unique partial match. So, okay, so if I did SD of my data, like, and like n equals true. If there is no other, and I don't know all the arguments for SD, if there's no other argument for SD that starts with an n, it will set NA remove to true. If there is though, that's not going to work because that's not a unique match. Again, the usefulness of this is questionable. but it's more or less, it's just like another way of using this. You don't have to write the full name of the argument, you can just use an abbreviated form as long as it uniquely partially matches to the argument you're trying to assign your value to. So if that doesn't work, then it'll just check for a positional match. So this would work anyway, even if n was not unique. This is in the second position, so if this is not unique, it was assigned true to the second position, which I assume is any remove. Alright. Yes, okay. So defining a function, this would have been helpful. Okay. So this is the general kind of framework for how you define a function. This function has no body, but this is the general premise. You're assigning, so f is going to be your function call, and then you use this reserved word function, and then your variables will be a, b, c, or sorry, your arguments will be a, b, c, and d, of which b, c, and d have default values. So b will default to 1, c will default to 2, and d will default to null, unless specified in your function call. So if I call function f, so let's say I want to set x to some call of function f. I need to give it at least one value because a does not have a default value. So if I just go like this will throw an error because it will say a does not have a default value. If I do f of 1, that will work. I mean, the thing is this doesn't return anything, so none of this is going to do anything. But in terms of not throwing errors upon calling the function, this will not throw an error because it's going to assign 1 to a. The rest of the arguments have values, so that'll be fine. But if I want to be more explicit, I can say, f of a equals 1. That does the same exact thing. And even further, I can say, f of a equals 1, comma b equals 2. And that way I've changed the value of b, but I've changed it from the default, but again, that's allowed. That's how you're supposed to use these functions, even if they have default or arguments with values.
Good question. So I think Michelle said that the arrow sign dash is equivalent to the equal sign.
Yes.
So why do they always you put an equal sign inside the function and the arrow sign dash? Is that just like a convention?
Sorry, what was that? So you're assigning. So this is going to be the variable name that's going to store your entire function.
Yeah.
So you're basically defining this function and then assigning it to this variable.
You could also use the equal sign, right?
Oh, I see what you're saying, like here.
Yeah.
I actually don't. So I don't think you can use the. So they're not exactly true.
Not exactly.
I think it was a bit of a stretch for him to say it's the same as.
Okay.
In most senses, like if you're doing something simple like x equals 5 or x assign 5 to x, they're the same. They're equivalent in that setting.
Okay.
But in this setting, the assignment function you can only have one assignment per line, if that makes any sense. So here you're assigning function to f. These ones, this is not an assignment function. This is kind of setting the value of to some extent. It's not exactly the same as an assignment because these are not values that are going to be used outside of this block of code.
So it wouldn't work if you had a bunch of those assigned things in one line.
I don't know actually.
Okay.
I don't think so, but it's something worth trying.
Okay, cool.
I've never seen like that, so it could be convention, but I'm not sure that you can do that. Alright, in addition to not specifying a default value, you can also set an argument value to null. So that's what he meant by missing arguments. You can define arguments that could be used but don't have to be used and set their default value to null. Again, questionable usefulness, but if it's something that, again, it depends on the context in which you're defining your function. Alright. Arguments to functions are evaluated basally, only evaluated as needed. Okay, right. So this is similar to what he was saying about missing arguments. So here you've defined a function with two arguments, a and b. But as you notice, your function only uses a in its execution. So even though b doesn't have a default value, you can use f of 2. So I guess what I was saying, the entire last slide is wrong, because none of those variables are actually even used in your function, so it won't throw an error. Because what I was saying is if you don't define a, it will potentially throw a function, but since your function doesn't do anything, maybe it won't throw a function. It's kind of a pointless scenario, but it may or may not throw a function if you don't define A, because of the lazy evaluation of functions, it's not going to use any of your variables because your function doesn't need any of your variables. Like if I were to just say function of all of these things and just put a 5 here, every time I call this function, it'll just return 5, and it probably doesn't need definitions for any of the arguments. You probably don't need to give it any arguments. So that's a similar situation here, where you've defined 2 different arguments to your function, but only one of them is ever used. So it won't require you to give it a value for b, even though you've defined b in the actual function definition.
So what does that mean? A, is that to the power of 2? Or
Yes, to the power of 2. Okay, so this function never actually uses the argument b, so calling f of 2 will not produce an error because 2 gets positionally matched to a. That's, again, not an entirely useful example, but good to know. Right, whereas here, your function has two different arguments, and then your function uses both of them. So if you try to just give it one argument, like 45, you're going to get an error if it says argument b is missing with no default. Though, interestingly, your number is printed before the error is triggered. That's because, right, b was not used until after a was used. So it started evaluating the function, printed a, got to the print b line, and then had nothing to print, and therefore threw an error. Okay. This is kind of confusing, but so the dot 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 argument. Again, this is a question of relevance to everyone, because I don't know how often you're going to be defining functions, and specifically defining functions that have dot dot dots in them. But dot 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 argument indicates a variable number of arguments that are usually passed on to other functions. So this is kind of like if you're extending kind of a different function. Like let's say you want to make like a custom version of mean that had some other additional options. You could kind of define mean and then take the arguments that mean needs and then put dot 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 to show that you can take other arguments and that those will be assigned kind of to other arguments inside your function. So, right, usually passed on to other functions. Dot to dot is often used to extend another function. You don't want to copy the entire argument list of the original function. So here we're defining a new version of myplot, a new version of the plot function using the we're calling it the myplot function. So, right, so you're just going to say x, y type equals 1, comma, dot, dot, dot. And you're using this dot, dot, dot because the plot function already, this plot definition has x, y, type, and dot, dot, dot. Because plot has a ton of functions, a ton of arguments. And if you don't want to type out all of them that are technically required to run the plot function, you can just use this dot, dot, dot function to say that all of the other arguments that plot can use can be inputted into the myplot function call, and they will be matched to the plot function call, but you don't have to write out all of those arguments if you're just extending the plot function.
So if you don't put dot dot dot, what would happen?
So that means if someone wanted, so let's say you wrote this myplot just for these 3 arguments, but then someone else wanted to use your myplot function, but wanted to use like some sort of like x max or x min, and they wanted to feed that into your function, it wouldn't take it. The dot 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 argument is also necessary when the number of arguments passed to the function cannot be known in advance. Right. Yeah, so these are great. This is probably a more practical use of the dot dot dot. So 2 things, these 2 functions, paste and cat. Paste being pasting 2 like strings together, or as many strings as you want together. Cat meaning concatenating as many strings as you want together. It starts out with the dot 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 because you can paste 2 things, you can paste 3 things, you can paste a million things together, and it will continually match all of those. But that means that if you want to that means it can't positionally match the rest of these. Does that make sense? Because if you start a function with dot dot dot, your positional matching goes out the window, because your dot 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 can be as many or as few arguments. So that means if I wanted to change the default separation that paste uses, I have to put in the things I want to paste and then put in specifically say comma sep equals like comma or something. Because if I just put in comma, it's going to think that's one of the things I want to paste together. Does that make sense? So this kind of, it changes your argument matching to some extent. So, an example of this. Just an example of this. Alright. Okay, great. Yes. So one catch with the dot 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 is that any arguments that appear after the dot 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 must be named explicitly, cannot be partially matched. I think he means positionally matched. So I think they can still be partially matched. But positional matching, right? So here we have, I don't know, I guess they can't be partially matched either. Alright, so they can't be partially matched or positionally matched. So here we have pasting A and B with a separator of colon. It's going to paste together A colon B. And if you try to partially match it by just putting SE instead of SEP, it just thinks it's another argument to your paste call. But again, importantly, you can put ABC and put the separation, and it'll do the same thing. You can take as many arguments, as many string arguments as you want to take, and paste them all together. Alright. So we can get to this. I probably just don't want to start this. But I'll just give you a brief introduction, but we're not going to get to the code for this. So again, so it's all good to know for and while loops, but in terms of doing things in I guess in the interest of doing things in one line, not that that should be the only metric you should be going for in your code. It's often useful to be able to create kind of complex iterative structures in a single line. And for that, R has these apply functions. And so there are 5 of these. Okay, to be fair, mapply, I don't know how many people really use mapply. They're really 4 ones that are used often: lapply, sapply, apply, and tapply. And these are essentially functions that loop over certain data structures and evaluate a function on each iteration. So lapply takes lists and vectors and basically applies a function to each element of that list or that vector. Sapply is the same thing as lapply, but simplifies the result to a vector or a list. Apply applies a function over the margins array. So apply can either be applying a function to the rows or columns of a matrix or data frame. And tapply applies a function over subsets of a vector. And I think we'll get into these next week because these ones are pretty important, and it's good to go through them slowly because again the function calls with applies are very condensed but do a lot of iteration in what seems to be very little code, which is very useful. It's good for creating concise code, but can also be very confusing if you're reading someone else's code and they heavily use apply and sapply. And you can kind of use these within each other, so you can apply an lapply. So you can apply a lapply call to like all of the rows of a matrix, and that will iteratively take each element of the row or column of matrix and then apply that to the entire matrix. So it gets you can put out a lot of computation in very little amount of code. So that makes them a little dangerous as well, because you have to kind of be thinking about what you're doing, what exactly you're applying to what. But again, very useful and much more condensed and concise than for loops and while loops. So that makes them pretty useful. So I'll leave that off until next time. I think we're going to go through the practical session. If there are any other questions, feel free to ask me. And I think we're going to start, I believe you guys finished the nuts and bolts R file last time. So I think we're going to start with the control. So I think we have two different R files. We have the control.r and functions.r. I think these are either you email them out or they're up on the website. do we take like a break or something?
Yeah.
Is that a thing? Yeah, we can do that as well. So let me get the camera. All right. So once again, I'm not entirely sure how Michelle does this, but I assume we just walk through the code together, evaluate as we go. Open to questions as always as we go through. So let's get started. So we're starting with the control.r file. Everyone's got that loaded up. Cool. So this first part, once again, we're going to evaluate our control structures. So we're going to start with some if and else control structures. So this is a kind of like a nifty little thing here. Our unif, you're getting kind of used to seeing these random number generated things. So this is our uniform.
Shrindra, what's happening on the on line 2?
Yeah.
Oh yeah. Okay.
What
So
is that?
Yeah.
so this is it's actually a pretty cool thing. I don't know too much about it because I don't do this, but knitr is this package that allows you to kind of output your as you run your code. You can output it in a kind of more reader-friendly way that outputs not only the code that you're executing, but also some of the plots and tables and like the return, whatever your functions are returning, and it kind of knits it, quote unquote, knits it all together into a readable format that you can then post on like, you know, it knits together like a document.
Oh.
Like that kind of outputs both your code as well as the outputs and puts it into like one kind of like thing. So I don't have knitr on mine locally, so.
Yeah, I get an error too. When
Yeah, so just you can ignore that. I don't know why he kept the knitr call on there. I think most people, it doesn't come by default.
Nope.
Yeah, it doesn't come by default with RStudio, so people probably will not have this. But it is a cool thing if you want to look up, if you are ever running a lot of R code and you kind of want to output, you're like presenting your data to like someone else who doesn't, you kind of want them to see the code, but you mostly want to see the plots and the different iterations that you've done. You can use knitr to kind of create like one kind of like summary of your code plus the outputs. But yeah, you should ignore that after all this thing. So anyway, so also I think you guys have one class in R, but again, the best way of kind of executing this stuff, not best way, but one of the best ways of executing is using what's it called, Max. Apple return allows you to run a statement directly from the script file instead of having to copy and paste it down into the actual command line. So we're gonna go and we're gonna generate a uniform random number between 0 and 10.
So you just hit return on that line, is that right?
Apple and return.
Command in that?
Sorry, command and return, yes. So what did you guys get? I got 4.82. Sorry, if you go, if you're curious as to what your number is, you can just go down to the command line and return X to see what number you got.
1.66.
That's a good one.
7.27.
Alright.
So did you highlight, so to execute this whole, I need to highlight it? So go like this?
We're talking about the R uniform?
Like the 1, 0, and 10?
Yes, so.
That's
so
what
R-
evaluated, but then to see X,
So I open it up here, so actually again,
you
you
need to
can,
go down here.
you can do question mark R.
Because right now, none of this told it to print out X. So X is in the computer, it's just not on your screen.
So
you
it's
just
kind of
ask
like
it what
profile.
X is, and then it will.
Okay.
So you see it's R unit, so this is actually a family of commands, but you see the R unit is here. So,
Okay, yeah.
and,
Sorry about
so
that.
that's your number of observations, that's like the number of numbers you want to get
So
back.
then you just do command enter.
And then you have minimum and your
And
maximum.
then scroll down.
So this 1, 0, 10 is going to be
Right.
one number
Yeah.
between 0 and 10, a uniform distribution.
Run, so X is equal to run, unless it's still evaluating.
Oh, mine is working now.
It might still.
Guys, we got something going on.
Yeah, I don't know what's going on here. Unless I accidentally deleted something.
Oh, I think there's a bracket problem.
It's here.
Oh.
The number of observations.
I think you just press escape. You can press escape to exit out. I think something happened where you highlighted. It must have been like somewhere. So that this plus means that there's either a parentheses or a bracket that has not been closed, so it can't evaluate your expression to close it. So if you get that, I would just escape out, because that probably means you just like highlighted. So that happens if you highlight like an open bracket but not a closed bracket, and you try to run it, it will kind of stall out because it's expecting you to finish it because it thinks there's more coming.
And then, sorry, Srinjoy, runif was just a random number generator?
Yeah, so it's basically a random number generator. Like you said, you can do question mark runif, but that brings up this help file. So this is a set of, so this is like density, probability, cube, or like quantile or something. And R, these are all for the uniform distribution. And again, so this takes three arguments. We have n, which is number of observations you want to take. Minimum of your uniform distribution, maximum. So this is essentially just saying give me one random number between 0 and 10.
Oh, great.
Alright, so now we all got our nifty, did it work? The execution? Did you try executing?
Yeah, but the third command worked, not these two, the first two. Yeah, this one worked, but not these two ones.
Really?
See, so the 1 to 10 printed out like 1 to 10, but not these guys at the top, even though the brackets and everything is fine.
Really? If you execute it. Oh, no, yeah, that's fine. So, because they don't return anything. So,
I see.
they
Okay.
did it, but which is weird. I don't know why he didn't have it return. So yeah, so if we run the next, the if else. So it runs it, notably nothing is returned because none of these statements say to return anything. So we're saying if x is greater than 3, set y to 10, otherwise set y to 0. But we're not returning x or y in any of these statements, so you don't see the output. But if you're curious, like I am, you can go down here and just say, give me x and give me y, and we can kind of see how did this all shake out for all of us. So my random number was 4.81233, which is greater than 3, so y was set to 10. For those of you, I think you said you have 1.66, for those of you who had a number less than 3, your y should be 0. So pretty standard kind of if-else kind of structure. Everyone okay with that?
Actually,
Yes.
kind of,
Yeah.
yeah. I guess we have to enter for each line. So I did the Apple enter there. I guess you're supposed to do it for each line, right? But now I got this like plus, and I tried to do
Yeah.
this.
So I think a lot of people are doing this. That comes when you have like an open bracket and you haven't closed it. Are things that you're still inputting more code, and so it starts getting confused. So the easiest way to break that is just pressing escape, and it'll cancel it out. But again, that happens when you have the wrong number of open or closed, or too many open parentheses or brackets.
So the
to
right way is
close.
to go line by line and do the command and command.
You can do line by line, or you just have to be careful when you take a block to make sure that's like a full block of open and close. So like it's like you can do like multiple lines at once.
How would you do that? Is
So I would just highlight from line 11 up to line 6, and you
then
run that,
Command and enter.
Yep.
Okay, got it.
and so you can execute the whole block. But it just starts getting confused if you have run, more open brackets than closed brackets.
It doesn't work though.
Was it?
It doesn't work.
Doesn't work. Yep. No, but yeah, you're ready to execute.
Yeah, it's me. Come on.
Uh-oh. Yeah, it's executing. So now if you go down here and you say, what is x and what is y? Mm-hmm.
Okay.
This is that none of that code returns anything.
We didn't ask to print X.
Yeah,
in the command.
exactly.
Ah,
It's not printing anything, so
I see.
it's executing but not printing because none of these commands tell it to print anything. Alright, similarly in the second block of code,
Yeah.
if we're going to set y, if x is greater than 3, to 10, else to 0. This is essentially illustrating that this is the exact same thing as before, but in a different way. The third line of code is a for loop. So again, for I in 1 to 10, This is a common structure that's in this in word in this kind of structure is a reserved word. That in becomes kind of like a special word because it's saying for I in a vector. So it's going to return. It's going to assign I every value in the following vector iteratively. So this is especially useful for loops when you're iterating over things because your vector doesn't have to be numbers. It can be strings or whatever, and it will iteratively assign those strings to I, and you can do stuff to them inside the for loop. But for here, we just have numbers, and it'll print out each one.
So I have a question for you. It's kind of pedantic, but let me
Go
ask.
for it.
So for I in 1 to 10,
Yes.
so in this situation, does it assign 1 through 10 to I first, and then print I 1 through 10, or does it assign I 1 first loops? Okay.
Yep.
So go.
Because if it assigned 1 to 10 to I first, then when it printed I,
It would just go 1.
it would go 1 to 10 in one vector.
One vector.
But here, when you see the return values, it's 10 vectors of length 1.
Yeah.
Everyone got that to work? Alright. So in this next part, right, this is a similar part before. X is this ABCD, and we're going to print out each element of X in a couple of different ways. This is perhaps the most straightforward one. We just have I in 1 to 4, and therefore again I will be 1 for the first iteration, 2 for the second iteration, so on and so forth, and therefore we print A, B, C, D in the 4 different iterations through the loop. Now we get to our friend seek-along. So we can, if you want to just see what seek-along does, so again, X is your vector A, B, C, D. If you just highlight the seek-along of X, and you return it, you'll see that seek-along X just returns the sequence from 1 to 4, which is why this for loop does the same thing as the previous one. And if you wanted to actually see what seek-along does, you can put question mark seek-along. Right, it's part of the sequence generation family, along with seq-len, which we'll get into soon. Seek-along takes one parameter, one argument, along with, I don't know why they called it that, but it's basically any vector, and it will return a sequence of that length from 1 to that number, or to the length of that vector. So run this, it'll give you the same output, ABCD. And again, probably the coolest one is for letter in X, print letter. So in this case, we're not assigning numbers to anything. Letter will just take the value of each of the values in the vector X iteratively. So letter takes the value of A, B, C, D in 4 different iterations. Which is kind of cool. Like this is something that I don't think you can do in Java or anything. Because in Java you have to actually create kind of a loop and use numbers as indices to access your vectors. But here you can, it does that kind of behind, like under the hood. Here you can just, it's as if letter is just taking each of the values from your.
Can you instead of letter put like integer? That's it.
Oh, yeah.
You could put integer or real number or whatever. It will.
Yeah, the letter is just a name. It's just a variable name. You could just say for X, I wouldn't say for X and X, but you could actually probably technically do that as well. But you can just say for I in X and print I, and it will return ABCD. Letter is basically like a local variable, but
Oh, I see. Yeah.
it's just like a variable that you're just printing within this block of code. But notably, I don't think letter will exist anymore. Letter does still exist.
Well, yeah. I mean,
Yeah, because it's just assigned
that's
the
the last
value.
iteration.
Yeah, exactly. Alright. And finally, of course, if your loop is only a one line, you don't need your curly brackets. You can just run it as is. But if your loop is any longer than one line, you will need to put curly brackets around it. Otherwise, it'll only take your first statement and loop your first statement without the rest of the statements. Alright. Next up, while loops. So here, pretty simple while loop. Again, you want to, before you run this, check that it will terminate at some point, and you can feasibly see it terminating. here very clearly we go from 0 and we're adding 1 each time, so eventually we will get to 10. So I think we're pretty safe. We can run our while loop, and it does exactly what we think it will, which will iteratively add 1 to each count and return it each time. Again, for and while loops are pretty great because they're very easy to read and understand what they're doing. Alright, so here. So this set seed thing, I don't know if he explained this before, you'll probably see this a lot in a lot of the practicals. Set seed, so the seed is something in your computer that R uses to generate random numbers. By setting your seed, you can ensure that you will always get the same numbers, even though it's quote unquote random. Your random calls will always give you the same results, and that all of us should get the same results if we set the seed to the same thing. Because normally it takes something like your date and time and sets that to the seed, and so therefore every time the time changes, your random number will change, your random outputs will change. But here, if we all set the seed to 1, we will all get the same coin flip in this binomial call. So this will be probably in a lot of practicals moving forward when we generate quote unquote random numbers. We want it to be uniform so that we don't get like different errors or different values that cause the code to break for some reasons. So we set the seed to 1. And again, if you want to read more about it, you know it's question mark set dot seed. And then, right, so this is that random walk thing, which is kind of cool. We're basically going to see from 5, do we get to below 3 or above 10 first, by flipping a coin. So I executed, and we'll see if you return Z now in the command line. What did you guys get? You all got 2? Alright, so we all
Good. This question. I had that highlighted and I pressed Z while and it deleted that.
Yeah.
What's the best way to undo that?
Just control Z, yeah.
Okay.
Yeah. That's the main hazard of doing this highlighting
Command
block
Z.
return.
Yeah, okay.
It's to make sure to switch to the command line before running stuff. So yeah, so we set the seed to the same thing, therefore we all get the same result, but theoretically if we all ran it on our own seeds, some of us would have ended it with Z at 11, and some of us would have ended with Z at 2. Oh, print Z's Alright, so we're not doing this thing, or that thing, or this. Okay, well, these are, so again, this compute estimate thing, I'm pretty sure does not exist. So I wouldn't use that as kind of your own time. Yeah, so if you look up a function and it doesn't know what it is or can't find it in any of the packages, it'll just say no documentation, you can try question mark, compute estimate, I actually don't know what that does, but I assume it doesn't help. Alternatively, if you get someone else's code and you see a function and you get the same error, a lot of the time that would be because that they're using a package that you don't have currently installed or currently loaded into your R. So if that's the case, you should just go back to that person, or normally the kind of way that people do it is they load in all your like packages and libraries at the top of your R file. So I just go back to the top of your R file and make sure all of the packages that they used are loaded in, because that is kind of like the main reason why you see some functions that work in other people's code but don't work in your code, because you don't have the right packages installed. I think if you have any questions about installing packages and stuff, we can discuss that outside of class. But it's pretty straightforward. But again, it's important that everyone's using the same packages. And yeah, I mean, in terms of good programming, there's a lot of times you'll put a line that says require and put a package name, which basically means that the code will stop running if you don't have this whatever package in the require statement loaded in. It's kind of like the best way of doing that. So yeah, so this example won't work. These other examples are, we can like look through them quickly. So for I 1 to 100, I is less than or equal to 20, you do next. That basically is skipping the first 20 iterations and then doing something else. And obviously, practically speaking, if you want to do that, you could just start at 21. but this is just kind of more examples of how you can do things. This next word is another kind of reserved word that you can just say, go to the next iteration without doing anything. And then finally, here's an example of break. So this is actually another way of doing the same thing. You go for I equal to 100, and then, I don't know, it's not the same thing. It's a similar thing where if I is greater than 20, then you stop the loop. Alright, so those are the control structures. Again, I think are picked up relatively intuitively. Probably the most important thing is this kind of like this in thing I think is pretty useful and pretty nifty. So getting a grasp on how to use that is pretty useful. The rest of this is, I think, pretty straightforward. A lot of basic R assignment and Booleans. So if we move on to functions, this one probably complicated, but let's see. Again, ignore line 2, so we don't have .r. Does everyone have the functions.r already? So here we're going to just define an empty function. Notably, you see the function call, when we define it, it doesn't have any arguments in it. It's just function, parentheses, parentheses. And this is pointless, but it's just giving you an idea for what is the practical syntax of defining a function. Find that. Right. So this class function is pretty useful. This is if you ran a whole bunch of code, especially if you're looking at someone else's code, and you're not sure it outputs some variable x, and you're not sure what it is. It's useful to use this class call to basically tell you what is x. So in this case, we're going to call a class on f. If you define, which is a function, it'll tell us f is a function. If I call this on, so you remember x from last time, if you call a class on x, it says it's a character. It's not going to say vector, because that's not really like descriptives. You can have a vector of integers, you can have a vector of characters, you can have a vector of doubles or whatever. So it'll tell you what is the type of atomic structure it is. So it's a character vector. So that's just like a handy thing to keep handy, so that you know what your variables are really holding. Because the class of an object defines what functions you can run on it and what functions you can't run on it. Like, I don't know if you guys talked about data frames last time, but data frames versus matrices, they look very similar, but there are a lot of functions that you can run on data frames you can't run on matrices and vice versa. So that's, but they both look like matrices. So it's good to use this class function to really understand why some of your code is failing, because it could just be something as simple as you have to convert your matrix to a data frame and then run this function on it. So if we execute this empty function, we get nothing, right? We say null. Sorry, I didn't mean to run the comments, but yeah, it will return null because there's nothing defined for it. Okay, so if we have the second function, so cat, again, it's concatenate, but also just like prints, returns things. So you'll notice actually it says hello world, and it also has this /n, that is a new line character. So there are a couple of those kind of like space characters. I mean, obviously space is just space, but /t is the tab character, and /n is the new line character. Just for your own use in like outputting stuff, it's helpful to know those couple of things. So we found this function, and then we run it. So notably, this function also doesn't take any arguments, so it's fine to just run it with f parentheses, and there, right, hello world. So that's fine.
So Srinjoy, for this is just saying that function's like an empty function, and then we're shoving concatenate hello world into the function?
Yeah, so this is no longer an empty function, but it just doesn't take any arguments. So that means when you run this function, it doesn't need any pre-existing information. You don't need to feed it anything. It will always basically have the same behavior regardless of.
Oh, so just as an output, doesn't have.
Yeah, exactly.
Okay.
It has an output with no input. which is, again, not a particularly useful type of function, but a function nonetheless. So here we get a function with an argument. So it's going to be a function of num. Again, you can call your arguments whatever you want. You can make it x. You can make it, I mean, obviously, good coding practices say that you should make it something descriptive so that someone who's reading your code understands what. It's not helpful to call, you know, I mean x, y maybe, but like, you know, like a, b, c, d is perhaps not the most helpful way of defining your arguments, just because they're a little more difficult to read. So here we have a function of number, and for I and seek length of number, we're going to print out hello world. So again, seek length was kind of like seek along, except seek length makes a sequence of length number. That was a little readable. So here, if number, and we're going to run it. So we have seek length of 3, which is what we're going to put in this function, is going to print it 3 times. Again, if you want to get a better idea of what seek length is doing, you just do seek length of 5, and you should see that it prints out 1, 2, 3, 4, 5. It's printing a sequence starting at 1 of length 5. Okay, perhaps not the most helpful of functions, but seek length, again, it just helps you be more robust to different lengths of inputs, just like seek along. Does that make sense? Here we have a bit more of a complex function. So here we're defining a variable. So again, it still takes only one argument, this number function, or sorry, this number argument. But we're defining a variable hello, which is hello world, this character string, hello world with a new line character. And then we're defining a for loop within our function that is basically going to print out your hello string the number of times that the number of number, NUM, sorry, this diction is getting confusing. So it's going to print that out, and then you're going to define a new variable, chars, which will take the number of characters of hello and multiply it by your number of iterations and return that. Alright. This will become a little more clear when we run this. I'm just going to define it first. That's defined. Right, you can assign your outputs to whatever variable name you want. So we just assign this to a new variable called meaning of life, which will run this function on the number 3. Right. So this is interesting, right? So he assigned f of 3 to meaning of life, but it also printed out hello world 3 times. So why is that? So as we said when we were defining functions, the output, the actual value output of your function is the last expression evaluated in your function. So in this case, that's chars. Meanwhile, these other hello worlds were printed because of a cat function. A cat function will print out whatever is inside it in the output. So in this way, you can kind of have 2 outputs to your function. Not really though, because you can't do anything with the hello worlds that are output. They're just kind of there. They're just returned, but they don't have the value anymore. Whereas the final value of your function is chars. So if I print out chars, we have 42. And that was gotten because number is 3, and I guess hello world /n is 14. So 14 times 3 is 42. I don't know where he gets these from.
Oh,
That's, yeah.
do you know what 42 is?
Yeah.
Do you know what's
Yeah.
42? Hitchhiker's Guide to the Galaxy. That was the meaning of life when
Yeah.
Well, it's the answer to the question, meaning of life.
That was
Sure.
the answer to the question.
The question was, what was the
The question was,
question?
it was 42. Bill Clinton was the 42nd president.
I don't know what this is doing here. Okay, yes. Great. So we defined a function that took an argument. So now if we try calling that function with no argument, we get an error just saying the argument num is missing with no default. So here, we're going to show same function, but this time the only difference being that num now has a default value of 1. So we're going to define this, and then we'll run it with no arguments, and it no longer has an error because it ran it with num equal to 1. Whereas we can still define the value for num, and it'll run it on that. So here we've just sort of stated that number num equals 2. This doesn't really matter all that much because this function only has one argument, and so whether we positionally assign it or name it, it'll always evaluate kind of the same way. Interesting test though is, now if I put a comma here, it'll think that this is the second parameter, or the second argument, but I'm naming it, so it shouldn't really matter, so it shouldn't throw an error. Okay. So it will throw an error. Because it's like it's assuming that there's some sort of second argument, but because it matched 1, but there's some other slot for another argument to be matched, but there aren't more arguments in the definition. So that's kind of how that works to some extent. Even though it correctly matches number to the correct argument. Alright, so this is going to so str is just gonna what is str? I assume it just makes a string out of something. Structure, correct. Cool. So this basically returns like the kind of definition of a function. So here we see that we have 3 parameters. You give it so you have three arguments, of which 2 of them have default values. The only one that you really need to return a value for is the number of values you want returned. If you don't give it anything else, it will default to a mean of 0 and a standard deviation of 1. However, we're going to assign values for n, mean, and standard deviation. But again, in terms of coding practices, it may help someone. I mean, this one's a little more straightforward that we have mean before standard deviation, but if you want to be entirely explicit to someone who's reading your code, it might be nice to say mean equals 2 and standard deviation equals 1, because if they're reading it, they might not know what those two things mean, or they might think that standard deviation is 2 and the mean is 1, or something else. So it's helpful to perhaps explicitly name the arguments that you're passing to your function call. So here we're going to play around with our favorite function, standard deviation. So if we look at the general structure of standard deviation, so it only has two arguments. It has x and it has NA/RM, which defaults to false. So first we're just going to positionally match our data to x and just keep the default value for NA remove. It gives us a standard deviation. Now we can also specify the argument by name, which will again give us the same value. We're still going to default to the false value for any remove. Also the same, but we can also explicitly define both of these arguments.
So could you go through that?
Yeah.
I don't see how you got that value. So what value did SD my data take in?
Right. So it took in my data.
Yeah.
Which
Which was 100, 2, and 1, right?
Right. So but it's the R norm of that. So it's going to be random numbers from a normal distribution. So it's going to be 100 random numbers from a normal distribution with a mean of 2 and a standard deviation of 1.
Okay.
So if I just take a look at my data, so these are all my numbers. So it generated 100 numbers based on this distribution, and now I'm just going to try to see what the standard deviation is. Obviously, standard deviation should be ideally close to 1, since that's what I specified my distribution to be, but obviously, as you take more and more observations, you get closer and closer to your actual standard deviation. So, I mean, 0.837 or whatever it was reasonably close to my defined distribution of 1 when I took my 100 values out. But if I were to do this 1,000 times, I would probably get closer to 1. I mean, similar to the mean. If I took the mean of my data, that's pretty close to 2.
Why are we all getting the same value because we're random?
Yeah, so that's because we still, our seed is set. So remember way back whenever we did the set seed is 1, it's still set to, I think it stays throughout the session, and then when you close out your session and you reopen your session, then it'll reset your seed.
It's an interesting question. I think that computers cannot actually generate random numbers.
Yeah, so they're not truly random.
It's always based on that initial seed, right?
Exactly.
So if you wanted to now remove the set seed function right now while it's open, can you do that? Is it possible?
I believe you can. So if you look up set seed, number generation,
That's probably a way to remove it.
seed. You could probably, set your seed to a random number. I don't know what the easiest way of doing that would be. But you could just set .seed and then come up with a function that generates some sort of random number. I'm sure it'd be cool that you could probably find a reasonable way of removing your seed without ending your session, because that should be a pretty common thing that people do. Alright. So we're almost done here. So finally we're gonna, as we did just on the PowerPoint, we're gonna go through this argument matching stuff. So again, you can reverse your arguments, you can reverse your argument order as long as you specify them by name. You're still totally fine. This will once again return the same thing. And you can also, you don't have to explicitly name both of them, especially if it only has 2 arguments. If you name one, it will default the other one to the first unassigned argument, which is x. So once again, return the same thing. So yeah, so LM, the LM function is the, actually I don't know what it stands for, but it's basically the linear fit function. I don't know what the point of that. I guess you can see all of the different arguments that are in the LM function, of which a number of them have default values, but the other ones don't. Though again, not all of these have to be assigned. You notice that weights doesn't have a default value, but in all of his examples in the PowerPoint, we never assigned any values to weights, which means that it's just not a necessary variable. It can be used, but is not necessarily used. I'm sure somewhere in the LM function definition, there's some sort of if statement that's if weights, is not NA, then do something with the weights, but otherwise you can just continue on without ever having to necessarily use the weights value. So here, function of a and b, we're only taking a squared. Again, this is the whole lazy evaluation thing, where even if you define multiple multiple arguments in your function definition, if it only uses one of them, you don't need to specify values for both.
So if I have to specify, then a to the power of 2 comma b equal to, how do I specify the value of b here if I want to?
In the definition?
Yeah.
Yeah, so you can specify a value. So you can just say b equals 5, and that'll specify, that'll be a fixed value. Again, not useful.
So the printout would be 20?
So this won't change the printout because you're still only evaluating a to the power of 2. But yeah, if you wanted to introduce a to the power of 2 times b or something, then you would change your output. So just changing the default value of b doesn't change anything because you're still not using the b value anywhere in here.
Is there different nomenclature for doing element by element operations, or like if you put like if A were a matrix and you did A squared, would it just do like squaring each element of A, or would it like try to do A times like A?
A times A, like dot product, or you mean dot product, cross product kind of
Okay.
stuff. I think it's gonna square each value, but that's a good question. I mean, why not find out, I guess. So fix this and do this. Yeah, so it's just gonna square each of the values.
Okay.
I think it probably coerces it to a vector and then just does it like that. I'm sure there are functions out there that can do dot products and cross products. Alright. So, right, whereas, of course, if you have two arguments that are necessary, and you're printing both of them, but you only provide it with one argument, it will match it to A, but it will notice that it has nothing for B, and therefore it will throw an error, but only after printing A. Also, kind of not in this PowerPoint, which is what we realized earlier, is that if your function only takes one parameter, or one argument, but you have tried to specify two, it will throw an error, the unused argument error, that says your function definition only had one argument, but you're providing with two, and therefore there's something wrong here, you don't understand what you're doing, kind of. Alright, that was mostly unhelpful. I mean, again, you could do like structure mean, but I would just return the first line of this. So you can type any function without any parentheses, and it'll show you the full code associated with that function. I guess it's not the full code. It'll show you it'll show you the structure of the call, as well as some other stuff that I believe is not very helpful.
So x dot dot dot, that means that it has a capacity to take whatever and then send it to.
Yep, that means it can take other arguments.
Yeah.
So if we look at paste and cat, again, these ones have dot 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 at the beginning, which means that if you want to access any of these arguments, you have to fully specify their name, which is what we'll see down here. Some cases here again, and here if we say paste these, right, it'll paste them correctly, A, B separated by a colon. But if you try to do the partial argument match, it won't work. But if you wanted to put C, not C, you can also do it. You can basically, this is what the dot 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 means. You can take more than two, or more than three, or how many ever arguments, paste them all together, and then finally, if you want to change any of the other parameters after the dot dot dot, you have to name them in full. This is also a good place where a lot of the times you'll get those other characters, like those new line characters or tab characters coming into play, or not. I guess this thing doesn't read those types of characters. Oh, that's interesting. Where's this one? Maybe it's this one. Nope. Yeah, this thing, I guess, paste doesn't read those types of characters as opposed. No, that's interesting. But paste defaults to space as the separator. And that's the end of the quote. Alright. So yeah, I mean, again, function definition will become more and more important as you get more and more into R, just because as much as there are tons of different functions that exist in there, the ways of stringing them together and iteratively assigning them or applying them to your data will change based on how you feed in your data. And what will be even more helpful is next week's lecture on applied functions, because that will probably be the most concise way that you can do it. And probably the more accepted in our community way of writing your code is, instead of applying it through for loops and iterating, just using apply functions and doing it in one or two lines, writing a very complex kind of function. Applies a lot of functions to a lot of data. And then kind of sitting back and waiting for it to run for like hours, which is what we do, I guess. Alright, so, I guess no questions, so, yeah. Also, I'm not sure if Vishal emailed you guys. I don't think there's going to be a practical this week, because I'm not around at the end of this week. So, I think there'll be probably like a mega practical next week on like all of R when he gets back. And next week, I believe, is Martin's lecture on differential expression normalization. So that's exciting. The fast statistician in here. Talk some real math. Should be fun.
Yeah.
All right. Thanks for coming.
Thanks.
Thanks for doing it.